The true shape of the Earth. It is not a globe.
Hello everybody, Steiner here. Welcome to Controversy Central, where we take on controversies that really matter. And if we believe the Earth is not a globe, we probably also believe the same as Laurie Frary.
We go by the premise that all globe projection, projection came from a real map of the flat Earth.
And here we have Adam Carter presenting the same concept in a slightly different way.
In reality, it is the globe which is a projection of the flat circular world.
And thus begins my analysis of how and why the flat Earth model failed in at least three major ways to even come close to representing the actual shape of the Earth. The globe model won hands down. The flat Earth model failed, as you can see in my last video, to unseat the globe as the reigning champion of representing the surface of the Earth as it actually is. And those were being overconfident, having the wrong facts, and using the wrong strategies for mapping the Earth. The first failure we heard expressed in the preceding two video clips. With no hard evidence, flat earthers show an overconfidence in the flat Earth model. This could only come about because of a careless disregard of the flat Earth model's most obvious failing, which is its misrepresentation of circumference, and especially in the far south. And because flat earthers have been overly confident in this, they carelessly embraced the wrong facts, which is error number 2, when they placed their confidence in the notion that the globe model was generated from the flat Earth model rather than the other way around. And a third major error, using wrong strategies for mapping the Earth, can be seen in the numerous flat Earth videos where their producers have attempted but failed to create a true scale model of the Earth. In this next clip, Adam Carter models the first two failings of the flat Earth by downplaying the failure of his demonstration of how to create a globe model from the flat Earth model. The exact opposite, by the way, of what I will be doing later in this video. So let's hear what he has to say.
The only layout that works for a map of the world, to include the dew line, is to have a circular map on which Canada and Russia face each other across the North Pole. Of course, it would be dishonest if I didn't bring the globe back into the picture as an alternative layout, but it seems that the only workable layouts are on the circular maps, or it's back to the globe again. The big question for you to answer is, if the circular map and the globe show the same thing, the only difference is that one of them has a curved surface and the other is flat. People seem to recognise the similarities between them, but for some reason Antarctica seems to puzzle some who can't quite grasp how a deep circular boundary has been condensed into a single landmass. It's almost counterintuitive, so I propose an exercise that I did when I first came to flat Earth. You can try this for yourself. I used a sheet of tinfoil as it holds its shape, but you can do this with a sheet of paper just as easily. Get yourself a small football, one of those 7-inch balls is perfect, and measure the circumference. It'll be a little over 21 inches. Now get your sheet of tinfoil and cut out a circle whose diameter matches the circumference of the ball, in this case about 21 inches. Get yourself a marker pen and draw the circular map with Antarctica onto the tinfoil circle. There are no pointers for artistic merit, but try to keep the land masses proportional. Include the equator and have Antarctica running around the edge. Once you've drawn your map out, wrap it around a ball and hey presto, you have your globe. You'll see that you really only need to scrunch up the southern hemisphere to turn a flat circular map into a globe, and Antarctica comes together nicely as a single landmass at the bottom. The circular maps are not that much different from the globe, except that one of them is flat and the other is spherical.
So in this video clip, though he acknowledges the need to scrunch up the tinfoil to create his globe model from the flat one, Adam Carter takes care to trivialize the most obvious and concerning problem he encountered. And that is the vast differences in circumference in the far south, forcing him to scrunch up the tinfoil at the southern extremities. As he said, and I quote, "You really only need to scrunch up the southern hemisphere to turn a flat circular map into a globe. And Antarctica comes together nicely as a single landmass at the bottom. The circular maps are not that much different from the globe, except that one of them is flat and the other is spherical." Unquote. Well, the experiment that I am about to present in this video will provide evidence that there is actually a tremendous amount of difference between his circular flat Earth maps and the globe. And that difference affects not only the vast southern oceans, but also large southern land masses like Australia. So before we actually look at these significant differences, which Carter casually downplays, let's take a look at how critical these differences can be in real life. To do that, the best approach I can think of is to take a look at the launch of Apple Maps in 2012.
In iOS 6, we have built an entire new mapping solution from the ground up, and it is beautiful. This is what Lake Tahoe looks like. We're doing all the cartography ourselves. Here's New York City, San Francisco. This is a worldwide effort. We're covering the world. Here's Italy, New Zealand. The beautiful, beautiful maps. Now, part of maps is local search. You have to be able to find businesses and points of interest. Here's our satellite view. But what I really want to show you is flyover. So let's go ahead and choose the Transamerica Pyramid. Let me choose another place. How about the Sydney Opera House? And again, I can rotate this. Let's turn it so I can look back at the city. Right behind the Opera House. I'll zoom out a little bit, change the camera angle. And that is flyover.
Now let me interrupt the Apple Maps presentation here for a moment, since what I have already shown in my last video indicates that we could very well highlight the Flat Earth map's greatest problems by concentrating a significant amount of our analysis on Australia. So here we have Scott Forstall unveiling the very first state-of-the-art, high-tech, elaborate, detailed, even at times breathtaking mapping system produced by Apple. What more can I say? Oh yes, it was also a worldwide failure on a grand scale. Showing the Sydney Opera House and then panning out to bring the entire city into view drew gasps of admiration from the audience. What they didn't know at that time was that, had he then either focused in on particular landmarks right there in Sydney, or panned out to include particular other locations in Australia, they might have then gasped in horror at the egregious and potentially life-threatening mapping errors that were there. Some of those errors, such as the ones mislocating hospitals or directing people to drive into oncoming traffic, were extremely serious. Others, like turning lakes into mountains, were merely amusing nuisances. Now back to the presentation.
Now, the last thing I'd like to show you is turn-by-turn directions.
Which, unfortunately for Apple, ended up being the last thing in a string of errors that resulted in some people finding themselves in life-threatening situations in the outback of Australia.
Can Apple Maps kill you? I'm Jen Markham on Buzz 60. police in Australia are warning the inaccurate maps could actually be deadly because the maps wrongly place a large town 43 miles away in the middle of the unforgiving outback. Police say they've rescued at least 4 people who became lost in the middle of Murray Sunset National Park while looking for Mildura Victoria, including one iPhone user who was stranded for more than 25 hours in the park, where there's no water and where temperatures top 109 degrees Fahrenheit. Australian police are now calling the devices potentially life-threatening. So if you really can't leave the house without your iDevices, at least take a canteen of maps, some matches, and a flashlight with you too.
Which, unfortunately for Apple, ended up being the last thing in a string of errors that resulted in some people finding themselves in life-threatening situations in the outback of Australia. And clearly Jen Markham was not suggesting that anyone bring along a flat Earth map. Because first of all, that is never the type of map the ordinary traveler uses when either driving or hiking into the Australian outback. It's always the type of map that is a projection of the globe. Why does it always have to be a projection, you ask? If the globe model is so great, why not just bring along a globe? You know, a scaled down version of the Earth. Forget the Gall-Peters or Mercator projections, or any other projections for that matter. Well, if the answer is not obvious to you, let me demonstrate. If we wish to carry around a globe model for traveling the highways and the byways of this world, or possibly for some wilderness exploration, we would obviously need to have it scaled down from the actual size of the Earth that we are traveling on. And not just scaled down a little, but scaled down a lot. An awful lot. To illustrate just how much smaller the scale model of the Earth needs to be from the actual size of the Earth itself for these and other uses, let's take a look at a few scale models of one part of the globe for which I happen to have just the right variety of maps that we need to make this determination. In this mashed up Google tour, we will be traveling up the sun-drenched Okanagan Valley, one of the most interesting places in Western Canada. This valley in the south-central part of British Columbia, which is the westernmost province in Canada, is ideal for demonstrating the need for map projections rather than globes for various practical purposes. This is a valley that is well over 100 miles long, nestled between the lofty Cascade Mountain Range to the west and the rugged Monashee Range of the Columbia Mountains to the east. Though not far from the Pacific rainforests that characterize the coast of British Columbia, it has a very sunny, hot, and dry climate. This providential characteristic of that valley, together with its stunningly beautiful and varied terrain, has been a powerful magnet for rugged adventure-seeking outdoorsmen as well as comfort-loving tourists. Since it provides an amazing backdrop and inspiration for urban luxuriating and wilderness sports and exploration, people are drawn throughout the year from various parts of the world to fly or drive there so as to participate in their favorite activities. Though its biggest city, Kelowna, has skyscrapers and a population nearing 200,000 people, the valley itself is set down in the midst of a vast and perilous wilderness. So, as we look at and evaluate the various scales of some of the maps modeling this area, it shouldn't take long to realize one very important thing, and that thing is the fact that nobody thinking clearly would ever consider hauling a globe up and down this valley and into the surrounding mountains for the purpose of finding their way around this rugged neighborhood. Neither, by the way, would they be using a North Polar equidistant azimuthal projection like the Gleason's map. Now, the globe that I've been using for my videos is actually a fair-sized one, being 16 inches in diameter. So the first thing we need to do is to take a look at just how much that model has actually been scaled down. As you can see here, its scale is 1 to 31,680,000. This means that 1 inch on this model of the Earth represents a physical distance at sea level of 31,680,000 inches on the Earth's surface. Or in other words, that 1 inch represents 500 miles. Now zooming in on the globe, you will notice that there is very little in the way of detail to be seen. In fact, the region we will be looking at in greater detail using other maps is so small and insignificant on a 16-inch diameter globe that there is nothing on the map to identify it. In fact, it is so insignificant that its location was chosen by the cartographer who made it as a convenient spot to place the letter O when writing out the name of the city of Vancouver. So unless its existence and location were already known, a person could be excused for not being able to locate it on a globe this size. Yet to cart around and actually use a globe of this size when traveling by car, for instance, would not only be very inconvenient, it would also be totally useless for actually plotting our route from point A to point B. But even so, it can still let us know fairly accurately where any point that has been plotted is in relation to any other point on the Earth that has been plotted on this model. Now this next map, being a commonly used projection of the globe that is far easier to carry around and use than an actual globe, is also a map that is now at a scale that makes it possible for it to contain information regarding the area I am interested in. Its scale is 1 to 2,100,000. This means that 1 inch on this map represents just over 33 miles. As you can see, we now have a sufficient amount of detail to actually identify the region we are looking at and its major roads and cities. But it's still quite cramped as far as I'm concerned. For ordinary road trips, I much prefer a larger scale map like this next one, with a scale of 1 to 250,000. At that scale, 1 inch on the map covers just under 4 miles. As you can see, it is much easier to read, especially under low light conditions. It also provides additional information that can come in quite handy at times. But for backpacking into unfamiliar territory in wilderness areas, I find topographical maps like this one with a scale of 1 to 100,000 to be the most useful of the ones I have at hand, since it uses an inch to cover just over 1.5 miles. Of course, maps with a scale of 1 to 50,000, approximately 1 inch for each 4/5 of a mile, are even better. But since topographical maps such as this one are very detailed, they also become a bit too bulky and awkward for most general use. So now we can see why it's not a good idea to be carting a globe around for general travel purposes. Since the circumference of my 16-inch globe is approximately 50 inches, to make a globe with the features contained on even the least detailed of the flat maps we just went through, the length of the circumference of that globe would need to be approximately 15 times the circumference of my globe, or 750 inches. This would give us a diameter of almost 20 feet, which would take a fair-sized living room to accommodate. Who can cart a globe like that around? You'd need a 20-foot tall ladder just to get high enough to see the North Pole at the top of that model. And imagine if someone was considering bringing a globe on a wilderness trek. At 1 inch per 4/5 of a mile, go figure. I mean, literally, go figure. Is it any wonder we have resorted to using projections, though they introduce distortion? At least when we introduce a deliberate, calculated distortion, that distortion can also be calculated out mathematically when necessary. And remember, these projections of the globe model are the types of maps that have been, and continue to be, used all over the world by millions, if not billions, of people whenever and wherever maps were needed. It's only been in the past few years that digital maps have also begun to be used for such purposes. So with all the flat earth flap I hear about all the maps being wrong, I've only one question. Why is it that everyone can get to his or her destination without problem by using one or another of these supposed wrong maps, no matter how far or to where that person chooses to travel? Except, of course, in the unique experience of Apple Maps users in the immediate aftermath of its initial release. And prior to the use of GPS maps, I don't ever remember hearing of any major panic such as the one that Apple Maps caused when they sent people into dangerous wilderness areas many miles from their chosen destination. Maps were so commonplace and so reliable that the average person didn't even think to question the general accuracy of the map that he or she was using. So we can conclude with total confidence that all properly constructed map projections work as they were intended. Even the North Polar Azimuthal Equidistant projection, believe it or not. And these facts I can explain in detail in another video at a later date. But for now, let's get on with the fun part. It's time to show how the grapefruit debunks the flat earth. So the plan that I have in mind is to plot on this grapefruit the locations of the very same pairs of population centers that I used in my last two videos, using the very same grid and coordinate system as well. Those of you who have already seen those videos know that those pairs of centers were chosen because each pair is approximately the same distance apart as each other pair. For this reason, I have cut up enough pieces of string of identical length to allow me to pair up these centers on the grapefruit. Another reason I chose those pairs was that some were directly north and south of each other, while the rest were directly east and west of each other. In this way, it was easy to identify the problem with a flat earth model. I was able to show in those two videos that both the flat earth and globe models were so accurate for north-south distances that given the scale of the models I was using, only insignificant differences between the actual and modeled distances were found. The same cannot be said concerning east-west distances. For those, only the globe model did not produce differences of any significance. The flat earth model introduced marked differences of greater and greater significance the further south I measured. Though I had been able to show the errors that occurred with the flat earth model and the extent of each of those errors, I was not set up to show how transforming an accurate globe model into a flat earth model would introduce those errors. So this is what I intend to do here. By the way, this is the exact same grid and coordinate system that has been used on the Gleason's map and on pretty much any other flat earth map that includes a grid and coordinate system. So as you can see, I've plotted out the grid and its coordinates on the grapefruit, and I've marked each population center on the grapefruit according to its coordinates. I've also used the same lengths of string to pair each population center with its partner location that is situated approximately 2,100 miles away. Now at this point, I've already begun the process of transforming a globe model into a flat earth model. To ensure that the flattened peel of the grapefruit can be seen to be a realistic physical representation of the North Polar Azimuthal Equidistant projection, I am leaving the strips of grapefruit peel attached to the North Pole position. This may take a bit of time, since I am being careful not to do anything to void the experiment and force myself to start all over again with another grapefruit. As you can see here, I'm about to run into a bit of a problem in peeling this part of the grapefruit. I have no choice but to take a knife and cut the piece of string connecting the markers for Perth and Newcastle in Australia. Otherwise, it will be impossible for me to straighten out the strips of peel and spread them to make a grapefruit peel model of the flat Earth. It will soon become apparent that whenever I cut through the strings going in an east-west direction, their ends do not immediately pull away from each other. That is, as long as the grapefruit peel retains its original curvature. And here, I'm cutting the string spanning the distance between Volochenka, Russia and Wainwright, Alaska. I don't expect to see this piece of string separate much, if at all, being this close to the North Pole. But as I begin to straighten out the strips of peel, you'll be able to see something very different take place concerning the strings going north and south from that which takes place concerning the strings going east and west. At this stage of the flattening process, we can already see that the results I recorded in my last video are taking shape. The distance between the southernmost two east-west population centers has increased dramatically, while the distance between the northernmost east-west population centers has barely changed at all. This strip of peel, on which I've marked the locations of Yellowknife, Canada and Aho, USA, does nothing to change the distance between these two locations as it is being straightened out. This again is to be expected, as it reflects the results shown in my video on north-south distances. Now we come to Malundu, Cameroon and Mogadishu, Somalia, both just north of the equator. Again, it would be impossible to straighten out these strips of peel and separate them in the transformation process without cutting the string. While the north-south strings, one connecting Algiers, Algeria with Lagos, Nigeria, and the other connecting Bukavu in the Democratic Republic of the Congo with East London in South Africa, remain as they were, the string going from east to west begins to separate. So as you can see, I have a bit of a problem here. I'll need to remove the peel from the grapefruit to make it possible to complete the transformation process. Well, I'm glad I managed to get that done without tearing apart the peel in any way. Okay, well now, let's see whether or not I'll be able to flatten this thing out completely without running into any problems. Okay, well, I've made it so far, no problem yet. There we go. I must say, it's actually looking pretty good. So now it's time to bring out the string that I had marked off into 1-inch segments for the previous 2 videos. I'm not trying to be exact here, considering the small size of the model that I'm using, but it will be interesting to get a rough idea of what we're looking at. In this video, the markings aren't all that obvious, but hopefully they will show enough for our purposes. What you are seeing is the string marked off into 1-inch segments, with one of those 1-inch segments marked off into tenths. So what we see here is a distance of 1 3/10 inches between Mulundu and Mogadishu. What it looks like here is a distance of 1 1/10 inch between Volochenka and Wainwright. And what we see here is approximately 3 1/2 inches between Perth and Newcastle. Now we'll take a look at the north-south pairs. The first is Aho to Yellowknife. The next is Algiers to Lagos. And the last is Bukavu to East London. So now we get into the final experiment that I will be doing on a grapefruit in this video. Here you can see a complete grapefruit peel spread out on a sheet of paper. I've drawn an outline of the peel on the paper with a circle drawn at the tips of the grapefruit to represent the outside edge of the most popular of the flat earth models. This is the paper with the outline that I drew around the splayed out grapefruit peel, together with a circle connecting the tips of the outlines of the strips of peel. Here you can see that I have cut out the paper that had been covered by the peel. What you see here is the end result of me taking the paper that had been under the peel, curving it around some balled up paper, and putting the tips into a styrofoam cup to ensure it maintains its shape as a very rough model, but a model nonetheless of a globe. The wedge-shaped pieces of paper lying around the base of the styrofoam cup represent the tremendous amount of extra land and water surface that you would find in a flat Earth model as compared to the actual Earth surface as represented by a globe model. Now, one of the really nice things about this experiment is that the cost of the tools and material that are needed is next to nothing. So anyone wanting to repeat this experiment should be able to do so with ease. I encourage everyone, especially every flat earther, to try your best to prove this experiment wrong. Then try to come up with a video to show that you can actually take a physically flat model of the Earth and transform it into a globe model without having to use every ingenious method you can come up with to hide the extra Earth surface. It can't be done, but the exercise may help you come to grips with and escape from the powerful influence of flat Earth teaching that has gripped your mind. In spite of the confident assertions of both Lori Frary and Adam Carter at the start of this video, they had it completely backwards. The only way that anyone can properly use a flat Earth model to create a globe is to do what I did: cut out large areas of land and water and discard them. This could prove to be very inconvenient for anyone who happens to be living or traveling in those discarded areas when you choose to do away with them. But the globe, on the other hand, can be transformed into a flat Earth projection by simply allowing extra space to be created between longitudinal lines as they are separated to remove all existing curvature. This extra space can easily be accounted for by using simple mathematical calculations. Showing or modeling this mathematical discrepancy on an azimuthal projection is far superior to having someone think to use it as a scale model of the area in which they are looking to travel. As we saw with Apple Maps, even a small mapping error of 43 miles was enough to put people's lives in mortal danger. Oh, and by the way, in case you were wondering whether or not Apple saw the seriousness of the situation created by their map, here's the lowdown on that.
Apple CEO Tim Cook released a letter to customers today to apologize for the frustration caused by the company's new Maps app. Cook promises that Maps will improve, but suggests that users take advantage of other navigation apps like MapQuest, Waze, or Bing.
Nick Vargas here with news straight out of Cupertino. This morning, Timothy Cook, Apple CEO, apologized for Apple Maps not living up to expectations. Apple Maps has taken heat for lacking walking directions, public transportation directions, giving incorrect driving directions, and calling corporate headquarters gas stations. Tim Cook recommended using competitors' apps, including adding Google Maps back to your home screen.
So in light of the serious issues that can crop up when a map that has distance and location wrong, even if that is only for east-west directions, is presented as an accurate scale model of the Earth, I urge Lori Frary, Adam Carter, and everyone else who promotes such a flawed view of the shape of the Earth to reconsider and abandon that view without delay. In fact, because of the results we have already seen when I transformed a paper model of the flat Earth into a globe, I'm inclined to think that if Adam Carter is being as honest as he claims, either his memory is failing him badly, or he was totally unaware of what was occurring before his eyes as he made the tinfoil in his experiment conform to the shape of the ball he was using. Most people who have had the experience of using tinfoil to cover a curved object, such as a potato, have also had the experience of seeing the unique way that tinfoil can be crinkled to tuck in and otherwise make much of the excess adhere closely to that object. So he clearly used the wrong material for his experiment. And I certainly don't want anyone who saw the clip at the beginning of this video of him explaining but not demonstrating his experiment to take at face value the conclusion that he came to. In fact, just in case this video is not enough to show him, or anyone else for that matter, how he managed to err so significantly, I intend to take him up on his recommendation and repeat that very same experiment in an upcoming video. Only I will be videotaping myself doing it in order to show what the actual results are. In fact, I will go above and beyond his recommendation. I intend to use tinfoil first and then paper. And I intend to do so in such a way as to be able to demonstrate that there will be large portions of land that disappear, along with vast expanses of oceans, as the flat Earth map is converted to a globe. Come to think of it, I wouldn't be at all surprised to even see one or more of major cities ending up disappearing from the face of the Earth by the time I'm done. So if you're interested in seeing how that turns out and haven't already done so, don't forget to click on the subscribe button below and then the notification bell to be notified as soon as I post each of my next videos. And thanks for watching.